So good morning again, everyone. We are looking at the strand, new and emerging jobs, and this strand examines the place for TVET in respect of key themes of sustainable development, especially in relation to skills demand for the contemporary and future workplace. Our speaker this morning, Mr. Darien G. Henry, PQP, is the high-performing principal of Cumberland High School in Portmore, St. Catherine, Jamaica. He served as lecturer at the Excelsior Community College and served as a senior teacher at Jamaica College and Darien High School. I hope I got that correct. Mr. Henry is also a trained inspector with the National Education Inspectorate and a facilitator in the National Lead School Inspector College of Educational Leadership. There's one thing that he asked me to remember, and I must say. He is the proud father of 2 sons, Darien Jr. and Devonte Malachi. He enjoys also cooking, beach volleyball, and reading. So let's now welcome Mr. Darien G. Henry.
Thank you very much. Good morning, everybody. Let me thank you for being inside of this concurrent session, where we're going to be delving into an unknown world, but it is certainly gaining significant traction. I am a finalizing student in the MA program in leadership in TVET and workforce development, and certainly it has given me a bird's eye view into emerging jobs and emerging opportunities. And certainly it gives me some kind of doorway into understanding the realities that are fast approaching on the Jamaican and Caribbean landscape. This morning we want to look specifically at Mechatronics Engineering. It may sound pretty new to you, and you may wonder, what does a high school principal has to do with Mechatronics Engineering? Well, it's a springboard out of one of my assignments I did last year, and quite a bit of research was done, myself and 4 other group members, and were invited to make the presentation. So we want to explore the rise of Mechatronics Engineering as a new and emerging job, and of course to evaluate the implications of the rise of Mechatronics Engineering, certainly. I really want to set the background really from a global perspective. High-speed internet, the growth of artificial intelligence, the use of big data and data analytics, those are the buzzwords of the multinational companies right now. And certainly, what is going to be happening in the next 4 to 6 years is going to be determining what are the types of emerging jobs, and certainly this is one of them. The World Economic Forum, their latest report, is telling us that 75 million roles will be displaced over the next 5 to 10 years as a result of the emergence of the exponential growth of new technologies. But while we're losing 75 million jobs worldwide, the World Economic Forum is telling us that 133 million jobs will be created, and certainly that will emerge over time. Now, the other part of the global picture is telling us something very unique. The division of labor, that is to say, the tasks that humans perform and machines perform. The current ratio is 71-29, 71% humans and 29% robots or cobots. What the World Economic Forum is telling us that by 2022, that ratio will shift to 58-42. So you will find that 58% of human tasks will be covered by humans, but certainly on the other side, 42% will be covered by robots. So there are exponential advances, and one of the main areas that this is happening is certainly in the manufacturing sector. And investors in this sector, they're utilizing all the opportunities available with the Internet of Things to ensure that their efficiencies gain traction. The assumption now is that by 2021, there will be an explosion in terms of investments in the manufacturing sector, particularly as it relates to the Internet of Things. Let's drill down a little bit. The manufacturing, engineering, and mining sector in Jamaica is gaining increased traction. And the latest statistics coming out of the Statistical Institute of Jamaica and the Planning Institute of Jamaica is telling us that the labor force is expanding. At the end of 2017, we had about 1.3 million workers on the workforce with an unemployment rate of 8.4%. 68% of Jamaican workforce is really geared in the manufacturing sector, or the servicing sector. When you drill down into the numbers a little bit, though, we find some troubling statistics that high school graduates, the ratio now is only about 25% graduating with 5 or more subjects. Now, the rise of mechatronics engineering is smack in the middle of the 4th industrial revolution. Yesterday, we were introduced to the tipping point of the 4th industrial revolution, and certainly the emergence of the mechatronics engineer is part of that tipping point. Now, the manufacturing engineering sector is among the growth sectors that is geared by the government of Jamaica to generate significant employment opportunities. And based upon the current numbers and the assessment and the statistics, it's telling us that the outlook for the MEM sector is extremely positive. Certainly with the promulgation of the special economic zone legislation, that too has provided a significant catalyst. Now, when you look certainly at the latest trend numbers from the Ministry of Labour, you will see that mechatronics engineer is becoming and has gained far more traction in the types of jobs that are becoming far more available in the manufacturing sector. Now, the question is, what is mechatronics? From a raw perspective, it is an interdisciplinary branch that pulls together some key technical areas. These technical areas include engineering, science, and computer science. So what is being done here is a blending of these key areas for this new and emerging job to be appearing. Inbuilt in mechatronics is robotics, which deals with design, construction, operation, and use of robots, which intertwines in it computer systems for their control, sensory feedback, and information processing. More and more manufacturing sectors are looking at far greater edges of efficiencies to improve their operation and output. Now, let me just unpack it a little bit before I move on. The word mechatronics is composed of 2 distinct areas. Mecha, which is the mechanical side of it, and the tronics, which looks at 2 areas, the computer science area and, of course, electrical engineering. Now, what is the nature of mechatronics engineering? It is certainly, as I said before, tied closely to the field of robotics. And the Ministry of Labour is telling us in their latest assessment that rapid advances in technology, which have led to a surge in public interest in automation and robotics. Remember earlier I said to you that over the next 5 to 10 years, the World Economic Forum is telling us that 75 million jobs will disappear, but at the same time, 133 million will emerge. But there is a perception that robotics will replace humans and they'll replace the opportunities presented to these persons. Now, mechatronics is extremely complex because it's dealing with actuators and sensors, signaling, conditioning, power electronics. Picture for me what happens in a manufacturing plant like Red Stripe, or what happens at LASCO. This is precisely where the investors are going. They're looking at the use of algorithms and computer hardware and software to manage complexities of the job much more so than humans. So what is essentially happening is that humans are creating machines to solve problems. And this is precisely what the mechatronics engineer is doing. They're looking at uncertainties. Yes, they're looking at communicating engineered systems. This is what the big companies are looking at right now. Yes? And certainly later on, we're going to be looking at some of the implications and what are some of the best recommendations to look at this. Now, according to Brown, a mechatronics engineer is a capable thinker. He's able to think in a holistic sense. The argument about critical thinking, especially at the lower levels, at the primary and secondary levels of the school system, is most paramount and most relevant. They're able to think holistically. They're focusing on certain specific elements, such as the mechanical system of a software. What is important, though, according to Brown 2008, many mechatronics engineers work with electronic instrumentation and computer control systems, which nearly all machinery relies for efficient and reliable operations. Again, the investors are looking at leaner, more meaner means to ensure that their operations are far more efficient. Now, look at the role that is played by the mechatronics engineer. Now, they have a role in project engineering, reliability engineering, and power engineering. The mechatronics engineer can work with any kinds of systems, and their strengths in IT, hardware, and software system help them to become what's referred to as versatile problem solvers. Now, Brown reasons that the mechatronics engineer by its nature involves extensive collaboration with people. So you're seeing here a vast integration of the use of the humans and the robots to ensure that problems are solved. Skills such as teaching and persuasion, negotiation. So not because the mechatronics engineer is so steeped into the technical side of things, the requirement for soft skills is also going to be extremely necessary. Now, let's look at the importance of mechatronics engineer. According to Australia 2018, it brings efficiency. And the buzzword going forward into the future right now, many companies are future focused. And inbuilt into the dialogue about being future focused is efficiency. People are looking to save money. Mechatronics adds intelligence to design of systems by which efficiency of the systems improve. The second one is important. It's a cost reduction mechanism because mechanical control systems are expensive. So when compared with these mechatronic solutions, certainly it lowers costs. So less work will be available for normal factory workers in the future. That's precisely what it is saying. It also improves design time, product size, and reliability, and it's also user-friendly and safe. They're also telling us that the mechatronic solution increases reliability, no sick leave, vacation time. These are things that are getting far more attention in terms of the reliability framework. Now, what's important as well here, and I'm going to explain shortly how the Caribbean Maritime University figures in all of this. It provides a good career scope. The demand for nanotechnology, biomechatronics and robotics is increasing in developing countries like ours. Also, the salary is extremely, extremely high. Now, what are the key trends that are driving the emergence of mechatronics engineer? Ubiquitous and high-speed internet. I know Professor Morris was lamenting the problems with Digicel. I could have gone and shake him hand yesterday, it's true. But guess what? It's going to get better. It's going to get better. The rise of artificial intelligence as well. Now, in the mornings, my sons get scared when I say, "Good morning, Google," or "Good morning, Alexa." And it tells me about my day. Yes? Widespread adoption of big data analytics, and this is central in the emergence of the mechatronics engineer. Cloud technology, and what the World Economic Forum is telling us, that the cloud technology is expected to dominate the business world after 2022. So there are some serious implications ahead. Now, the World Economic Forum also is telling us very, very poignantly, in order to harness the transformative potential for the fourth industrial revolution, business leaders across industries and across the regions will increasingly be called upon to formulate a comprehensive workforce strategy ready to meet the challenges of this new era of acceleration, of change, and innovation. Now, what are the local trends? As I mentioned earlier, the Caribbean Maritime University is positioning itself for a significant takeoff. They are now offering engineering degrees in mechatronics and automation through their School of Engineering. They spent about $400 million over the last 3 years to promulgate upon our country the Festus Authorized and Certified Training Center, which will deliver global standard certification in mechatronics. So we are going to be preparing engineers not just for the Jamaican Manufacturing Center, for the manufacturing industry, but for the global manufacturing industry. What we're seeing is that companies all over the world, Coca-Cola, all of them, they're going to be sending their apprentices here to be trained and certified. In the presentations this morning, a lot of emphasis was placed on certification, yes, as distinct from qualification. And the dialogue and the discourse must now take some significant foothold about the importance of certification. The director from JCTI spoke about the certification being the pathway to professionalism. And certainly even in the teaching profession, the dialogue and discourse about certification is becoming even more relevant. Now, let me show you a photograph of the Festus Center at the Caribbean Maritime University. As I said before, they spent $400 million to make this possible. I was fortunate enough to be given a tour last year, and Mr. Flores, he's the director of the center. He was trained at Coca-Cola, and he's now a sought-after world leader in certifying mechatronics engineer. This kind of facility is now offered in Jamaica. It's now here, and they're getting far more aggressive in opening their doors to ensure that cohorts upon top of cohorts of young people, they get inside the Festus Center to be recognized and certified as the world leaders. Now, what are the implications, you may ask? Machines, of course, will overtake humans in terms of performing more tasks. I showed you the ratio earlier, where there's a significant reduction in the number of hours carried through by humans as distinct by robots. This is one of the professions where it's happening in a significant way. Developments in automation technologies and artificial intelligence, as I mentioned before, will see a significant displacement of jobs. And this will also not only affect the manufacturing industry, but banking and finance as well. NCB and the Grace-owned First Global Bank, they are running far and center to ensure that they're making their operations much leaner and meaner to provide the services to members of the public. And this is also what's happening in manufacturing. Now, the mechatronics discipline is attracting students to be part of the new era of industrialization to support advanced product development. So younger people, yes, younger people are being attracted more and more in this area. Companies are looking to diversify. Amazon is looking to diversify. The Chinese-located Apple-owned Foxconn, they're looking to diversify their operations as well because they're relying upon new skill sets to make their businesses far more efficient. Enable the interdisciplinary engineer to look forward to high-quality job satisfaction. Yes? The new concept requires strong scientific background, and I'm going to be talking a little bit about this in the recommendations here. There has to be tremendous leapfrogging in the education system now. We have to move from the incremental standpoint. We should have been far ahead with PEP 10, 15 years ago. I was telling a lot of my colleagues that we in education, we complain too much. We need to embrace innovation and change so our young people can take a significant foothold on these new and emerging jobs. We here in the Caribbean, particularly in Jamaica as well, we need to have a far greater understanding of labor market trends as it relates to these new and emerging jobs which have high technical skill competence. There has to be greater investment, and this too comes from a policy perspective. Greater investments in industrial certification. It's expensive, yes, but is it worth it? Yes, it is. We also have to look at developing occupational standards. I try, as a TVET leader myself, I try to look 20 years into the future and 50 years into the future. The landscape, ladies and gentlemen, is going to change significantly. We have to make the right decisions at the policy level, at the school level, to ensure that we take significant foothold in this new and emerging job. We have to also deepen the critical thinking and conceptual exploration at the primary and high school level. We need to stop the complaining. We need to start the doing. All right? So, ladies and gentlemen, these are my recommendations. I thank you very much.
We just have about 2 more minutes. We'd like to invite your questions, questions, comments. Going once, going twice. Wonderful.
Mark Broomfield, former president of Jamaica Basketball Association.
Thank you.
I'll use that one. Interesting your comment about mechatronics. What I want to ask is, where are the jobs? Because sometimes we make the mistake, because I teach lecture engineering students, and I do this as well. The job in these areas lies in research, developing and selling technology, not in using technology.
Yes.
Because we do not have the space to employ 200 mechatronics engineers. So if we don't start looking at creating things. I was in China last year and I went to a factory that they said we have 2 patents per week.
Yes.
If we do not spend in research and development and creation of things, we are not going to be having these jobs because the job is not, we purchase most things.
Yes.
So I want to know what your thought is on where is the job going to be? Is it in the learning of these technologies? Because Red Stripe not going to have 200 engineers.
That's right.
They probably have 1, and the rest of them are technicians. So where is the opportunity in these areas of mechatronics?
Thank you very much for your question, Mark. I did make reference earlier to 2 very important things. One, which I think we're not leapfrogging enough in the area of the special economic zone. No, the government of Jamaica came up with a brilliant idea to earmark a specific geographical area for the promulgation of factory operation and manufacturing operation, so to speak. It is going to come, I can tell you, but it's going to take a while. Yes? We have to get into the mind frame of preparing for this to happen. We cannot sit back and when they happen, we're not prepared. Also, we're living in a global space. The jobs that are being created in this and other emerging areas is not just for one defined geographical space. Jamaicans are working all over the world. They're moving beyond Canada and the United States. They're working in Mexico, they're working in Dubai, they're working all over. And Jamaicans are the ones who are getting themselves certified. But what this does, what Jamaica does, is positioning itself, and the positioning is important as part of the discourse about research. You can research all you want, you know, but if you're not positioning the system and if you're not positioning the opportunities, it won't happen.
Yes, Madam Chair, I have, good morning. I'm Halden Morris, University of West Indies, Mona campus. Thanks for the presentation. I think it hits where we need to hit in terms of where we need to go. I'm not so much concerned about where the jobs are, as the previous question that came forward, but more concerned about our education system, curriculum change to embrace these movements. Yes. I know that we are preparing persons for the world of work, and we are preparing persons not just for Jamaica, but internationally. There are no boundaries to where you can go. The best persons can come from Jamaica to work anywhere else in the world, go to Dubai, wherever the job is. But the point is, our training system needs to reconfigure itself. And I just wondered if the Education Ministry is here to understand, to start looking at a curriculum change, because there's a very significant change that needs to be made to the curriculum as it stands right now. And not just to include TVET, as we call it, because in our definition, TVET is really to saw a piece of board and to hit a nail with a hammer. Yeah. And we are not looking at how we really deal with TVET at the higher levels of the technical skills.
Yes.
So I just wondered if you could respond to that.
Yes, certainly. Excellent point, Professor Morris. In my mind, I'm of the view, and I've written extensively about it as well, that there has to be a transformational mindset that take a foothold with policymakers in Jamaica. The mindset has to change, yes? As an inspector myself, I go into a lot of schools to look at teaching and learning. In my own school, I've disrupted it entirely. I'm getting my own staff and students to be thinking future-focused. As a matter of fact, we sat down, Professor Morris, to look at our mission statement. And we had to redraft our mission statement to say, we want to be a future-focused institution. We want to signal to the world that what we do in teaching and learning must prepare the children for the jobs of the future. I agree with you that the entire curriculum system, the entire training system has to also be stung by a mindset change. And it begins with us as leaders. I consider myself a leader in TVET, so whatever I can do. But I have to take the signals from the policymakers. And certainly, the dialogue has to continue. The advocacy must continue. It can't be business as usual. We have to embrace the transformational mindset. We have to reimagine education. Yes? In my bed at night, sometimes I say, where do I take my school? Where do I see my school in 15 or 20 years? That's the kind of mindset that's needed.
Owen Wilson, Minister of Education. I am one of the curriculum officers, and the question was asked, where is the ministry in reforming, making the adjustments in the curriculum? I can speak specifically to the National Standards Curriculum, the grades 7 to 9 aspect of the curriculum, looking at industrial techniques. At the primary level, we refer to it as engineering and mechanisms. The effort was made to do what we would call introductory or basic level automation or robotics, an introduction to those kinds of principles and thinking. When you look at the resource and technology syllabus, or curriculum I should say, the idea behind engineering is not specifically towards the career, but the way you think about a problem, regardless of the nature of the problem. How do you strategically look at a problem to create a solution, and a workable one, regardless of the nature of resources that you have around you? So I could go a little bit further to say what schools like JC, KC, Immaculate is doing in terms of robotics and the introduction. They're moving it from just, getting a robot to pick up an object, but now to look at how you interface the technology in your physics class, in your PE class, and the other subjects. Because parents want to move from just a competition to see how now you can benefit from the skills gained in a competition for further progress, yes, your occupations and so on. A couple months ago, we had our first, First Tech Challenge competition at JC, and there are about 20 schools participating directly and indirectly. So you had schools participating and some came on just to view what was happening. So I could talk about CXC making the adjustments now to include computer-aided drafting as a means of assessing technical drawing candidates for exams. So I think all of those things are coming together to create a platform for the development of what we are looking at here. It's slow, because you're talking about also teachers rethinking the way they teach, and we know what happens to some of our teachers. But we're getting there, and I think we are getting bigger buy-in. So it's for us to continue to do the push to have the kind of output that we're looking forward to.
Okay, excellent intervention. 2 quick points, though, in response. One, you mentioned select schools that have gone into a deep dive where this is concerned. This is good. But we cannot divorce from that a disconnect between schools that are resource rich and those that are resource poor. Yes, there is a significant imbalance, and before we can become aggressive in that argument, we have to address that imbalance. The second part of the argument is about the teacher mindset. We do have a teacher mindset issue in our industry, in our sector called education. We have to get our educators to think beyond being just teacher, yes, to being the facilitator, the troublemaker, yes, to reimagine. I want a teacher to go into a classroom of rambunctious boys and get them to be thinking. But we find the lamentations about salaries and so on. That will take care of itself. But the teacher has to be a reimagined practitioner.
As a result of my assignment, I must say that you have done good research, you have done it well, and you have presented it well.
Thank you.
So I commend you.
Thank you, Dr. Powell. Thank you so much.
You have been talking about mergers and blending and change. I noticed that the higher educators, a company that you are in, speak about massification, bringing minds together by all means, by the cloud. And the engineer will tell you about densification of the earth to get the tolerance for the building that will go above it. And now you speak about the merger of mechanics and electronics, the mechatronics. But there is one thing that our good ministry has done, and Owen didn't remember to tell you, that there is now a merger between the TVET unit and the General Studies unit.
Yes, yes, yes.
That is the beginning. Because this complementarity which we speak about in terms of the academics and TVET, this is what is going to change the mindset of all, and it's going to answer Prof's question.
Yes.
We have to see the merger there.
Yes.
So when we speak about the TVET unit, which is now the TVET unit, which is now no unit at all on its own, it is now merged with a unit of general studies or core curriculum. I don't remember what they call it. Used to call it core curriculum. It has begun. And I would ask the region to take a look at this, the rest of the region, to take a look at this kind of merging, because everything is one. And I am not in agreement with prolonging a discussion that there is 80% or 85% of the world of work that deals with TVET. The entire world of work is TVET.
Absolutely. Absolutely.
So thanks for your presentation.
Thank you so much.
It was very good.
Thank you very much, Dr. Powell.
So we want to thank you for quite passionate, quite a dynamic sharing. We want to thank Mr. Henry and participants for being present and sharing in this quite futuristic presentation. So thank you.